Here's pre-calc. This is problem 7-93, and it's about vectors. It says three forces act on an object of negligible mass. The forces have magnitudes and directions as follows. So it has these three vectors, and they want to know what are the magnitude and direction of the resultant vector. I think we know that resultant means to add them. But the problem is, a lot of times when we add vectors, we do it graphically from head to tail, but not with three. So I did initially think I was going to just add these graphically, and I drew a diagram, but it soon became apparent that you'd have to be very, very exact drawing the diagram. So there's a better way. There's several ways. One of them would be the Desmos geometry calculator, but in that calculator, it won't let you input magnitude and direction. It only lets you input component form, like a ordered pairs. So no matter which way we do this, we have to get these into component form, and that's easily enough done if you remember how to do it. So basically this, I think I drew a diagram. This first vector, this first force vector, it has a magnitude of 23 and it has a direction of 16. So I just draw an XY axis, and I open an angle of 16 degrees, and then I make a, I don't know, in this case it looks like a hypotenuse of 23. That kind of helps me remember how I can get the components. I can get, because you know how like sine, let's look at our SOHCAHTOAs. Sine is opposite over hypotenuse. So I could say the sine of 16 is opposite, that's y, over hypotenuse. So sine of 16, let's write this all out. Sine of 16 is opposite over hypotenuse. And then if I multiply both sides by 23, which is the hypotenuse, I get that the vertical component is 23 sine 16. Similarly, if I want to get the horizontal component, I just go, well, that comes from cosine, because that's adjacent over hypotenuse, so I would just write cosine of 16 equals x over 23, and that's how I get 23 cosine 16. If you do enough of these, like in a couple chapters from now, you won't be drawing any diagrams. You'll just know that you're going to use cosine for your first order, for your first component, and sine for your second component. So basically, here's my three vectors, and I just typed in 23 cosine 16 into my calculator, and I got got all these numbers. 23 sine 16, if you put that in your calculator, you should get 6.3. I'm in a degree mode. I did it for all three vectors, so here's all my three components. And then if I wanted to, I could type them into Desmos, but really it's so much simpler just to stack them up and add them. So I just stacked them up and added them. Like here's the first vector, and the second vector, and the third vector. I just added all the vertical components, and it came out to negative 10.6. I add all the horizontal components, turned out to be 0.7, so we had some negatives in there. So that would give me a vector that went right by 0.7 and down by 10.6, and then I can just I drew a little triangle so that I can put it back in magnitude and direction instead of component form. So I can get the magnitude by Pythagorean theorem, and so I've done that here. I ended up with a magnitude of 10.6. I can get my direction by, I used the tangent, because tangent is opposite over adjacent, so I'm trying to find theta, so opposite over adjacent, so I said tangent of theta is 10.6 over 0.7. I can inverse tangent both sides, and I get theta is negative 86.2 degrees. Or you could have written that as 273.8. Either way, it's pointing down here in quadrant 4. And so that's actually just the answer right there. I did, since I have a little bit of time, I did actually draw it out to make sure that it would make sense. So I actually drew it to scale. I used millimeters for my magnitude, and I used an actual protractor to measure my angles, and I started out, I drew the first vector just at 16 degrees. That's exactly 23 millimeters right there, because we're used to the head to tail method. So I start here, there's my first vector, now here's my second vector. Remember, it had a magnitude of 100, and it had a direction of negative 85 degrees, so that's why it's kind of like, if that was the if this was the x-axis, it's like almost going straight down like 90 degrees, but it's not, it's 85. So it goes down there. And then the last vector had 88, so I'm going to draw that 88 millimeters, and that direction is 110. So that would be like, that's 110 degrees right there. And then I actually measured out my millimeters, and I ended up right there. And this little tiny baby vector right here, this is actually about 10 millimeters. It actually, when we did the math, it was 10.6. That's because maybe I'm not perfect at drawing, or maybe my rounding. And it has the direction. Remember, we had 86.2. Well, or negative 86.2. Well, that's almost negative 90 degrees, and it looks like it's heading that way. So there's just a diagram of the problem. But honestly, you're just gonna just do it this way from now on. Just put everything into component form and just simply add them up, and then convert it back to magnitude and direction.